Hello friends, welcome to Chemistry Nuggets where you can polish your knowledge and clear those friends. Today's video is question number 2.33 from NCERT textbook class 11 and the chapter name is Structure of Atom. So let's check the question. What transition in the hydrogen spectrum would have the same wavelength as the Balmer transition n is equal to 2 to n is equal to 4 to n is equal to 2 of helium ion spectrum. So here friends, they are giving that for helium ion, the transition of electrons start from n is equal to 4. So it will be n initial, that is 4, and it finishes on the n is equal to 2, that we can say n final. So this value is given and they are asking for hydrogen atom, what will be the n initial and n final. If wavelength of helium ion is equal to wavelength of hydrogen ion. Now this is the brief of what question is asking for. We need to find the value of n initial and n final for hydrogen spectrum. So we have a clue that we have wavelength lambda. So let's start. We have one formula, 1 upon lambda means wavelength. For helium plus we can say it will be, the formula is R into Z square. Here Z is the atomic number. 1 upon n final square minus 1 upon n initial square. This is the formula. Now we'll put the values in the formula to get the lambda value of helium. So R we can write simply, need not to write the values. Z here for helium it is 2 square, 1 upon n final is 2, it means 2 square, minus 1 upon n initial is 4, means 4 square. Now let's solve it. R into 4, this is 1 upon 4 minus 1 upon 16. Now calculating in between inside the bracket, we'll get R into 4 into, it will be 16 of 4 minus 1. So it will be 1 upon lambda He plus will be R into 4 into 3 upon 16. 4, now cancel it, 4 is 16. We'll get the value 1 upon lambda He plus is equal to 3 by 4 R. Now we get the value of lambda He plus, or we can say 1 upon lambda He plus. From this we will proceed to the value of hydrogen n initial and n final. Let's see, again we will put the same formula. Let's see how to do. For 1 upon lambda hydrogen, it will be R into 4. Hydrogen Z will be 1 square, 1 upon n final square minus 1 upon n initial square. Now as we know 1 upon lambda He, it will be 1 upon lambda hydrogen. So we can put the value of 1 upon lambda He here. It will be 3 by 4 R. Now it is R, 1 square is 1, R into 1 is R into 1 upon n final square minus 1 upon n initial square. Now R and R will be cancelled. So we can get 3 by 4 is equal to 1 upon n f square minus 1 upon n initial square. Now after reaching to this stage, we need to use the hit and trial method to get the values. So we can write using hit and trial method. we can assume that we can reach 3 by 4. It should be 1 by 1 minus 1 by 4. If we subtract 1 by 4 from 1, we'll get 3 by 4 easily. So we'll using here 3 by 4, we can write 1 upon 1 minus 1 upon 4. So from these values, we can get some idea. It means 1 upon n f square is 1 upon 1 or 1, and 1 upon n initial square is equal to 1 upon 4. So we can say 1 upon n f is equal to 1 upon 1 and 1 upon n initial is equal to 1 upon under root 4. 1 under root or square, same thing. So here from here we can get n final will be 1 and n initial will be under root 4 is 2. Here we'll get the values of n initial and n final. So we can conclude our problem solution is that the electronic or electron transition in hydrogen spectrum is from n is equal to 2 to n is equal to 1, which is having the same wavelength as the helium ion spectrum when n is equal to 4 to n is equal to 2. So friends, that's all for today in this question. Very easy. No mathematical calculation is there. So only logic based answer. Keep on watching the videos and do keep like, share and subscribe. Till then, thank you.